Hi, I'm Cameron with CanCam CNC machines, and today we're going to go through the process of squaring your machine. We're going to start off first with all of the tools you might need to go through this. We're going to go through the reason you might actually want to square your machine, or at least check the squaring. And we're also just going to go through the entire process from start to end of squaring up your machine. So looking at our tools here, there's not going to be too many that you actually need. This is a precision screwdriver set. We'll need a few of these bits along the way. This is a set of Allen keys. We'll need a few of these along the way. This is a square. We're going to use that to kind of test our material, see if our cuts are actually coming out square. This is just an impact driver. This is going to speed up the process a little bit. We have a 4mm Allen key driver in there. And then over here is our square. This has been machined down to be perfectly square, so we know we can use this. Here is a magnetic base that we will use to set a dial indicator on. And then this will be our dial indicator that we will use. Depending on your level of precision, you're going to want a certain tolerance of square across the machine. Here we have a test cut we've done. We've made sure in our programming that it's a 90-degree corner. And we have our square here. So this is just a quick check that you can do to compare your 90-degree square to what your machine is actually producing. And using this will verify your level of square for your machine. And we can see a gap near the top of the square where you can see light showing through, and that's proof that our cut here that we produced is not perfectly square. Depending on what material and products you're producing, you're going to have a certain level of tolerance. Here at CanCam, we have a tolerance with our machines of 1/1000th of an inch across a distance of 12 inches. Now that goes for both the x-axis and the y-axis, so it's 1/1000th for each one. If you're making cabinets, you might have lower precision. Maybe you'll have even higher precision if you're using certain material and certain dimensions that require it. If you're doing just a custom sign for a friend, maybe you don't need that tolerance, so you're fine with 5/1000th of an inch, 10/10,000th of an inch. So depending on your goal here, you can adjust your tolerance, but in this video, we're gonna go for 1/1000th of an inch on both axes. So looking at our machine here, we have a custom spoil board setup. Ideally for any precision process, you're going to want to remove that spoil board and work directly off of the PVC bed of the machine. Now we've had this permanently affixed, so we can't remove it. We're going to do this demonstration process on this spoil board. We're still gonna go through all the steps you wanna take, but when actually doing this, it's recommended to remove the spoil board or at least push it back to have a clear, clean space. Clean includes the surface, vacuum it, blow the dust away. Your block here, make sure its surfaces are clean as well, and steps like that are going to give you the highest precision that you can get. So we've set our block on the bed here, and we're just kind of guessing approximately if it's going to be square there. And we set our dial indicator up here on our magnetic base. Moving this base to mount it somewhere here. We're looking for something magnetic that this will, of course, attach to. With this machine, there's not many options around that are directly attached to the spindle, but we have our shroud right here, made of steel, so we can set this up and attach it to the side here. And then we'll move on to the next step of lining this up against the block. So we've got our magnetic base and dial indicator mounted. We're gonna now bring this in to the block here. And we're always gonna start on this y-axis. And we're gonna make sure the block is perfectly square on the y-axis, and we'll move to the x after. So just bringing it in a little closer, making sure not to crash it into anything. Bringing the Z down. And then we're going to lower the speed a little bit as we bring the Y and X closer in. We always want to start on the end of the block. I'm going to bring the Z down a little bit more. That should be good there. And now this is where the precision comes in. We're going very slow on the X, and we're going to wait till that indicator touches. And we'll bring it around, maybe halfway around this dial. And we'll zero it out. And this is our starting position. So this is going to be a sequence, a little bit of trial and error, just seeing where this dial indicator goes. So we're on the Y axis and we're going to move it at a relatively fast speed. And we're going to watch as that dial turns, and that's going to tell us what way we need to move the block. So we can see that it went clockwise away from 0. So we're going to move it to the other end, and we've actually bottomed out our indicator, so we're a little bit too far. So let's bring it back around here, and you can either tap on the block lightly here or tap on the block from behind, and that's going to slowly rotate the block. And you can watch as this dial moves what way it goes. Our goal is to bring that back approximately to 0. So if we're tapping here, you'll see that's actually slowly bringing it around to 0. And we actually got it pretty close, and we're just going to verify that by bringing it back. We're going to zero out our indicator here. And then we're going to run it across the block. So that's about 6 inches, and we're about -2 thou. And this is about a 12-inch block, so we're about 5 thou out across 12 inches. We're going to try and clean that up a little bit. So we're going to tap on the back of the block now to get this dial to go clockwise. So we're at 0. Let's verify that. Bring it back to this end. Zero it out if it isn't already zeroed. This is fairly close. We're going to run it. We're at the 6-inch mark. Still on 0. And going to 12 inches. We can see we're within 1/1000th of an inch, if not even better. So right now, our block is perfectly squared on the Y-axis, so we'll move on to the X-axis. So we're moving our dial indicator onto the block to check the X-axis. We're just lining that up, bringing the Z down a little more. X looks good there, and then we're going to go to our lower speed, and we're slowly going to move till that dial indicator touches. Yeah, approximately half turn there. You can of course adjust the small steps of this process, but we're going to zero it. Sometimes I have a little trouble with that, but we got it zeroed. Switching to the x-axis for movement, we're going to start going positive on the x-axis and watch how our indicator moves. And you can already see we are significantly out of square. So starting at 0 here, maybe 2 inches in, that's about 15 thou, and we've actually bottomed out our indicator. So things like this can actually happen if you crash your machine. It can send it way out of square, or potentially you've hit some material, maybe you've crashed a tool into the back tool rack. Small things like that can make big changes to your precision of your machine. So looking at our gantry here, we have our cover on the left, and it has some extra equipment with it. You can see we have our probe on the front here. That means there's some extra wiring in there. And we also have an oil pump on the back of the cover. And we're gonna try and avoid dealing with that. So what you can actually do is leave the cover on over there. But over here, this cover has no additional equipment on it. You can remove it and it comes off as one unit. We're gonna try and do all of our adjustments over here. And if it all goes well, we won't even have to touch the left side of the gantry. So this is where our impact comes into play. It's gonna help speed this process up a lot. There's a few bolts on the front and a few bolts on the back of this cover. The reason we need to take this off is because we need access to the bolts that actually attach to the gantry here. And there's also cables for our motors that we may need to adjust as well. So going through, we're just gonna take these bolts out with our impact. You may want a second person supporting the cover as you take these out, as you get to the last few specifically. So you can see the cover's already starting to drop there. We're gonna move around to the back. We're gonna make sure we don't lose these bolts as well. And we have 2 bolts that I'm just gonna take out here. There's also a few bolts that hold this cover to the side cover here. We're gonna remove that. So with 2 hands, we're gonna remove this cover. You should slowly be able to move it away. Make sure you don't bump anything too hard. And you're welcome to use an extra person to help lift this at the same time, of course. And now we have access to our gantry bolts. So we've got our 8mm Allen key. We're gonna use this, and we're gonna do the easiest step first, which would be adjusting these 6 bolts that hold the side to the upper gantry. So you're gonna loosen all of these. They're gonna be very tight. You might need a few tries. There we go. Again, 3 up the front, 3 at the back. And we're doing this one first because if we're lucky, we can just move the gantry a little bit in a certain direction with these, and that should be good. If not, we'll have to move on to another step. So we've loosened our 6 bolts here. Now we can move this gantry a little bit in either direction. The process of moving the gantry is completely up to you. Here at CanCam, we've used you can just use your hand. You can pull it either direction or push it. We've also used rubber mallets to hit the gantry potentially backwards or forwards. Another trick you can possibly use is actually loosening only 5 of these a lot, and then very slightly loosening a 6th bolt. Sometimes that can give you a little more control on how far you push it left or right. So what we're actually looking for is for that indicator to, of course, stay within a thousandth of an inch across about 12 inches. And we're looking to see which direction we pull it and how it affects that indicator. Here, we're pushing on the gantry and we're trying to get that back to 0. So we know that we need to move the gantry back on the right side to bring it back closer to 0. So we're gonna loosen and move that gantry and get it as far as we possibly can in square. And if that doesn't work, we'll move on to another step. So pushing the gantry, we've made our adjustments and we're gonna see what that results in. It was a little bit of trial and error, but here we're going across the block. This side is about 16 inches, so we're probably at 9 or 10 here. Looks like about 3 thou out. And coming to the full end of the block, this is around 16 inches. We're actually at 5 or 6 thou. So we've tried our best to get as much movement as we can out of those 6 bolts, but we're still around 6 thou out from where we need to be, depending on your precision level, of course. So we're gonna have to move on to another step. This involves disconnecting the motor and moving the motor and the whole side a little bit to see if we can get those extra thousandths back to square. So we're going to disconnect our motor here. What that is going to do is actually, in a sense, unlock the motor for movement. So these are just quick connectors, you just unplug them. Now that we have unplugged this, we're going to want to make sure we don't try to move the machine around too much with the controller. In fact, it probably gives a driver error that it won't allow us to move it. So now we have a lot of movement here to work with. And with those 6 bolts loosened, this step should be enough to get most machines back to where they need to be. So again, you can either push this back or you can bring it forwards, and you're going to watch your dial indicator to see how close you're getting to your precision level. So I'm going to pull on a part of the side here, and I'm going to watch my dial indicator as I'm doing this, and my goal is to bring that within a thousandth of an inch, so as close to 0 as possible. So as I'm pulling, I am getting movement out of the indicator, and it's actually getting pretty close to 0. And I'm going to stop there and we'll verify the results, see what it looks like. So we're going to verify our results here. We're going to move it all the way back to the beginning. We're going to 0 it out. And then we're going to run it across. That's about halfway. And we still need to get a little bit more out of it. So this is going to be a bit of a trial and error process. We're starting at the beginning again here, and we're just checking our run. So we're at about 2.5 thou. We're going to make some adjustments to the side again. I'm going a bit past where I actually want it. And then we're just going to keep checking. And you're just going to repeat this process until you get it where you're happy with the level of square. Do your run across the block. And coming to the end, this is actually 16 inches of distance. So we got it within a thou across 16 inches, which is a very high level of accuracy. Typically we just do 12 inches, but this is going to be very good. So we've got the precision we want, but we don't necessarily have this all buttoned up right here. So we're going to shut the machine down. And this is where we can now plug the motor back in. And what this does is lock it back in place. So we're just going to connect these. So those are in. If you don't turn the machine back on when you're going to tighten your 6 gantry bolts, you're going to move that gantry side out of square and you're gonna have to restart your squaring process. Now you're not gonna want to tighten all 6 bolts necessarily one at a time really tight. What we're gonna wanna do is a bit of a pattern where we tighten one partially, and then we move to another one on the other side, tighten that one partially, move to another one, tighten that one partially. And we're doing this slowly because if we did one very tight, it's possible it's gonna move our gantry a little bit and throw our precision out. All right, thank you for joining us for our walkthrough video of squaring a C2 series CanCam machine. If you need any support, we have our support email, which is support@cancam.ca. You can reach out to us. If you need any tools, any replacement parts, there's certain wear items, you can of course contact us and we'd be happy to help you out.